scalars and vectors. What are scalars? Any physical quantity such as mass, time, or these are all scalar quantities, and quantities such as position, velocity, force, these are all vectors. So a vector generally has magnitude, direction, and point of application or origin. So vector has three quantities in order for a vector to be completely specified. Magnitude, direction, and point of application or origin need to be known. So now what are unit vectors? So we generally use our x-axis, we have y-axis supposed to be vertical, okay. So and then we say this is a point P and this is our position vector, x coordinate and y coordinate. So this is our position vector. This is now when we write the position vector, we say if you want to go from the origin O to P, we write x I cap plus y j cap. What this means is if you want to go from origin O to point P, you have to travel x units along this unit vector and then travel y units along this unit vector. So this I unit vector is nothing but a unit vector in along I. This is j unit vector is unit vector along j. So this is unit vectors by definition have a magnitude of 1, generally direction vectors are unit vectors. These specify only the direction, are used to indicate only the direction, okay. Now this vector can also be written as, let's say if you define a unit vector t cap in this way, right? So then your position vector can be written as x I cap plus y j cap, or simply p t cap, where your p is nothing but x square plus y square. So you travel distance p along d to go from O to P. That's what this means. Now how do you get d cap? D cap is simply x by p cap plus y by p j cap, p being the magnitude of the vector. So magnitude is basically the length, okay. So this form is ideally suited when you know the magnitude and do not know the direction, that in those cases, okay. Now since we spoke about ijk, we will also talk about unit vector triad. So I, we know this, j and you have k cap. So I cap is typically unit vector along x-axis, y cap is unit vector along y-axis, and k cap is unit vector along z-axis. Okay, so cross product of two vectors. So if you do I cross j, you get k, and so we know so we have to use the right hand rule. So use your open your palm, and your first in the cross product, your first vector is your I cap. So if you put your fingers along I cap and then move them towards j cap, close your fist towards j cap, and then the thumb, the direction in which your thumb is pointing, will be the cross product of I cross j. So I cross j is k, and then k cross I is j, and then you have j cross k is I. These three are mutually perpendicular unit vectors. Okay. So if you are writing these in vector form, so I cap is nothing but 1, 0, 0. It has magnitude of 1 in x direction. J is similarly, you have 0, 1, 0, and your k is 0, 0, 1. Okay. We have our u cross v is u v, magnitude of u, magnitude of v, sine theta k cap, where you have your u and your v, and this is your angle between them, and your k is perpendicular. This is u cross v. This is perpendicular to both of them. This is how we generally do the cross product. Now, there is another way of another form of writing the cross product, where we write u cross v is equal to u2, and here u3 0 minus u1 minus u2 u1 0 multiplied by your v1 v2 and v3. This is your 0. This is your cross product matrix representation of the cross product. Okay. So generally in our cases, we have, when we want to find a moment, we have r cross f, right? So this, and especially when we are dealing with planar vectors, both the vectors do not have the 3 component or the z component. So this turns out to be 0, 0, 0, 0, r2 minus r1 minus r2 r1 0 times f1 f2 and 0, if we are dealing with planar vectors. Okay. So what this ends up being is simply minus r2 r1 multiplied by f1 f2. So in case of planar vectors. So dot product is simply dot product of u, let's say u is u1 I cap plus u2 j cap plus u3 k cap. V is v1 I cap v2 j cap plus v3 k cap. Dot product is simply, so this is, we are writing this as u1 u2 u3, we are writing this as v1 v2 v3. So u transpose v will give you the dot product. Said when we know a vector, you have, this is the point P, point O, and if you know the theta, this is t cap. If you know t cap can also be simply written as cos theta sin theta, right? So t cap is a unit vector. This is 1 unit. This is theta. So this will be simply 1 cos theta. Your x component will be 1 cos theta, y component will be 1 sin theta. So direction, if you know the theta, you can simply directly get the direction vector.